For all theta in the range 0 less than or equal to theta less than 2 pi, the line y minus 1 times cos theta equals x plus 1 times sine theta divides the disk x squared plus y squared less than or equal to 4 into two regions. Let A of theta denote the area of the larger region. Then A of theta achieves its maximum value at one value of theta, two values, three values, four values, or all values of theta. Okay, I think my instinct here, and the best way to figure this out is to just sketch the geometry of the problem and just try to visualize what's happening. I can see right away that the slope of this line will be tan theta. If I take the equation y minus 1 cosine theta is equal to x plus 1 sine theta. If I just divide by cosine theta, I have y minus 1 is equal to x plus 1 tan theta. And then let's rearrange again. Y is equal to x plus 1. Maybe I'll write this as x tan theta plus tan theta plus 1. So let's just sketch out where this line is. Okay. So when x is equal to 0, and theta is going from 0 to 2 pi. Okay, so we do have a lot of, and we'll have to be careful, when cosine theta is equal to 0, I guess we just get a vertical line or a horizontal line or something like that, right? Yeah, if that's equal to 0, then the whole thing is equal to 0, and we have x is equal to negative 1. Okay. Maybe another way of figuring this out, and I'm sort of like, I have a bunch of different ideas coming through my mind as I work through this, and I'm not really pursuing any one of them very, very far. Another way of looking at this is we see that the point x equals negative 1 and y equals 1 are kind of important. The line will always pass through this point, negative 1, 1. And then it's just a question of figuring out, and then we just need the slope of this line, right? So why don't I put that line there, negative 1, 1. And the disk is of radius 2. So the disk we're looking for is that one. Sorry, had a minor technical difficulty there. Okay, so as I was saying, the line always passes through this point and it has a slope of tan theta. So when theta is equal to 0, the line, of course, looks like that. And as it rotates, when is it going to have its maximum? So I guess it'll have a maximum when it's a 45-degree line. Right, the function a of theta, right? Remember that a of theta, this function, is the area of the larger region. So when theta is equal to 0, a of theta is the area below, the area of the circle below this line. And if I fix a point and draw several different lines through that point, and I'm looking at the area of the larger region, that's going to be maximized when the line is perpendicular to the closest point on the circle when the line is closest to that segment, or perpendicular to that segment. So when we're at 45 degrees, we'll have a maximum. Okay, so that's when theta is equal to pi over 4. That gives us a maximum. And as I keep rotating around, when theta is equal to pi over 2, right, that's when we have the vertical line, like I said, x is equal to -1. Now there may be local minimum or maximum, which won't really count, right? When the line has a slope like that, and it divides the circle in half, then a of theta is going to reach a local, that'll be a minimum, in fact. So we need to keep going around, and when, I mean, it's the slope is kind of, it's like a directed slope, right? Like theta represents the angle at which the line goes up. That's sort of what it means for the slope of the line to be tan theta. So when we're at 45 degrees and we're at whatever that is that 135 degrees, something like that? Well, it's also when theta is equal to 5 pi over 4. So when the line is pointing in either this direction or this direction, that's when the area is maximized. And so there are two values of theta which maximize this, and the answer is B. Okay, so this was figured out just by looking at the geometry of the problem. Rearranging into this form was maybe not the best thing to do, but I was sort of I did a little bit of a backtrack in my mind. I realized that, of course, we can only write it in this form when cosine of theta is not equal to 0. So then I started thinking, what if cosine theta is equal to 0? Then, of course, that means we must have x is equal to -1. But once I started to look at this term, I started to think about the pair of these two terms and realized that these two terms alone immediately tell us one point which must always be on the line. And then the geometry is actually really easy to figure out. You know, knowing one point that's on the line and the slope of the line allows us to visualize what's going on here very quickly. Yeah, the other key is realizing that if I fix a point and draw several different lines through that point, then the maximal area that we want is going to be found when the line we draw is perpendicular to this segment where the point is closest to the edge of the disk. Yeah, nice little problem. Really test your intuition on figuring out some of this geometry stuff. And I like that it's not heavy into, you know, the geometric formulas or anything like that. I'm typically terrible with those types of questions. So yeah, this is a nice one. If I have more to say, I'll write it down in the description. Thanks for watching.